The Earth often speaks in whispers. Recently, scientists detected faint murmurs. These came from deep underground. The signals were subtle, almost imperceptible. They originated near the New Madrid Fault. These were not the violent jolts of an earthquake. Instead, they hinted at a slow, unfolding drama. A mystery was brewing beneath our feet. The planet was sending us delicate, puzzling clues. These readings were unusual. They puzzled geologists. Standard earthquake sensors barely noticed them, but highly sensitive instruments listened carefully. They caught the signals. The Earth seemed to be sighing, a long, slow exhalation. This indicated movement, not a sudden fracture, more like a gradual yielding of ancient rock. A hidden transformation was taking place. The data suggested a quiet kind of collapse underground. Location is everything in geology. This was no exception. The whispers came from the New Madrid Seismic Zone. This region has a dramatic past. It has unleashed giant quakes. So, even tiny anomalies here demand attention. Scientists knew the fault's immense potential. Any change could be a sign. This vigilance unveiled the silent collapse. The New Madrid Seismic Zone is a name etched in history. In 1811 and 1812, it awoke with fury. A series of colossal earthquakes struck this region. They were among the most powerful in North American history. The land buckled and tore. The Mississippi River itself recoiled. Church bells reportedly rang in Boston, a testament to the Earth's incredible, slumbering power. The New Madrid Fault is a reminder, a geological giant. It sleeps, but its history tells us it can awaken. This legacy shapes our understanding of current events. How do you see a collapse miles underground, especially a quiet one? Scientists became geological detectives. They used advanced technology. Think of it as a medical checkup for the Earth. But the patient is vast, and its depths are mysterious. They needed tools that could peer through rock, tools that could measure incredibly small changes. The Earth guards its secrets closely. Unveiling this event required remote eyes and ears. One remarkable tool is INSAR. It stands for Interferometric Synthetic Aperture Radar. Satellites orbit Earth, beaming down radar pulses. These pulses reflect off the ground and return. By comparing radar images taken at different times, INSAR sees tiny movements. It can detect ground sinking or rising by millimeters. INSAR data revealed a subtle depression, a slow, localized sag. The ground itself was evidence of the hidden event. This was a key piece of the puzzle. Scientists also used seismic reflection imaging. This is like an ultrasound for the Earth's crust. Special trucks generate controlled vibrations, or small explosions create sound waves. These waves travel down into the Earth. They bounce off different rock layers. Sensitive microphones listen for these returning echoes. Geologists analyze the patterns. This revealed a void. The shifting Earth. Understanding the why. Why did this underground section give way? What forces were at play? Scientists are investigating several compelling theories. One prominent idea involves changes in fluid pressure. Deep within the Earth, rocks are not entirely solid. They contain tiny pores and fractures. These are filled with fluids, mostly water. Imagine a sponge, saturated deep underground. If the pressure of these fluids changes, rocks can weaken. They can lose their ability to support overlying layers. What could alter these deep fluid pressures? Natural geological processes are one possibility. The Earth's internal plumbing is complex and ever-changing. Fluids migrate, temperatures shift, minerals dissolve and precipitate. Human activities can also influence subsurface fluids, things like deep wastewater injection or oil and gas extraction. However, initial studies suggest natural causes for this specific collapse, long-term processes within the ancient fault system itself. Another factor is stress redistribution in the Earth's crust. The crust is always under stress, from the slow dance of tectonic plates. These stresses can concentrate in certain areas. Lessons from history. When the ground shook. The Great New Madrid earthquakes of 1811 to 1812 offer vital lessons. These were not singular jolts. They formed a terrifying sequence. Multiple powerful shocks struck over several months. This pattern is common in some major earthquake zones. The ground did not just shake once and then rest. It continued to heave and tremble, relentlessly. This prolonged agony deeply scarred the landscape, and the minds of those who experienced it. The physical impacts were astounding, widespread and dramatic. Huge landslides cascaded down river bluffs. Large tracts of land sank, creating new lakes. Reelfoot Lake is one. Other areas were uplifted by several meters. Deep fissures split the earth open. They spewed sand and water. This is liquefaction. Saturated soils turned to quicksand. This historical evidence reveals the sheer scale of possible change. The Earth's surface became an unstable, alien landscape. How does the silent collapse compare to these historic cataclysms? It is different. It is not a violent, ground-shaking earthquake. The ripple effect, infrastructure, and our safety. This silent collapse, though not violent, raises serious questions. What are its implications for our modern world? Our cities, roads, bridges, and pipelines rely on stable ground. Infrastructure in the New Madrid region is built with earthquakes in mind, but design codes are based on past, sudden shaking. A slow, creeping collapse presents a different kind of threat. It can cause gradual, uneven settling, stressing structures in new ways. This insidious damage can accumulate over time. Consider vital lifelines. Pipelines transport oil and natural gas. Levees shield communities from devastating floods. If the ground beneath these structures slowly deforms, they are at risk. A tiny, unnoticed crack can widen. A slight misalignment can worsen, leading to eventual failure, perhaps during another stress event. The silent nature of this collapse is its danger. Damage might go undetected until a critical point is reached. This requires new ways of monitoring and maintenance. Public safety is always the highest priority. The silent collapse itself did not cause direct harm, but it serves as a potent reminder. The fault system is active. Eyes on the Earth. The path to preparedness. We must remain vigilant. Keep our eyes on the Earth. Continuous research and monitoring are essential. The Earth is dynamic and ever-changing. Subtle changes can happen quickly. Understanding the New Madrid Fault system is a marathon. This knowledge empowers us to make smarter choices. Science illuminates the path to resilience. Scientific findings must be shared broadly.